Next point, students, the graph between energy and radius. For these energies, and radius means distance from the nucleus. This is R versus energy. This is a positive and negative, plus minus. Kinetic energy is always positive. You will get the graph on the positive side. Energy, total energy, potential energy, total energy are negative, so you will get the negative side. All are rectilinear hyperbolas because energy is inversely proportional to R, kinetic energy also inversely proportional to R, potential energy is inversely proportional to R, and interrelation is total energy equal to minus of kinetic energy equal to potential energy by 2. So nature of the graphs also important. Rectangular hyperbolas. Graph diagram they will ask you at identify which is correct one. Next is problems. Problems from the material. Question numbers may vary. You check up that questions. In the hydrogen, question number 2. For question number 1 is why hydrogen atoms do not produce X-rays, means energy level is different. To produce X-rays, we require high Z number, high melting point metals. How do you get the X-rays when fast moving electrons are suddenly stopped by the anode metals? Between the cathode and anode, high potential is produced, more than 10,000 volts is kept, and electrons strike this anode metal plate of high melting point and high Z values, and loss of kinetic energy converted into X-rays here. So to produce these X-rays, one thing required is large kinetic energy converted to X-rays. That is called as a continuous spectrum. Contains the range of wavelengths starting from beginning to the end. The spectra, X-ray spectra, starting from lambda 1 to infinity. This is the energy relationship. These are X-ray spectrums. If the voltage is increased, then electrons can penetrate into the inner orbits of this atom of this anode element, and the excitation of these atoms takes place and produce the radiations. Similar principle you can take for the production of the radiations, but wherever the R is there, you have to replace with Z square into R. More Z, more energy is possible. Less wavelength means more energy possible. So higher voltage if you take, you will get the graph like this. Lambda shift to the left side and corresponding the energy, maximum energy corresponding lambda also shift to the left side. It is not from 0 place, it's some values will be there. These are threshold wavelength, the starting value, and goes on increasing infinity. Very high voltage, these voltages, more voltage, more kinetic energy, more energy of the X-rays. X-ray energy is equals to HF. Here kinetic energy of the electrons we take in terms of equal to related to the potential difference EV naught. And X-ray energy is nothing but equal to EHF. In the X-ray production, HF or EHC by lambda. Kinetic energy is converted into this electron energy, means current is converted into photon energy of X-rays. The energy for X-rays is HF, and that is related to EV naught. EV naught is equals to HF. This is for the characteristic spectra, continuous spectra. That is only kinetic energy converted into photon X-rays. But electrons go into the inner orbits, means they can produce the characteristic spectra of this particular element. The characteristic spectra lies on the continuous spectra. This is a continuous spectra. All when starting from beginning, every valence is present. Characteristic spectra of the particular element is present. Only few lines will be there. This K, depending on the shells, K shell electrons are excited, or L shell excited. K means innermost orbit, L is next to first star, n equal to 2 is the L series, L shell word. When electrons are revolving around the nucleus, they move in the circular orbit, we said. This is 2-dimensional, circular orbit related to 2-dimensional, but the electron rotates so fast around the nucleus such that it looks like a spherical in all directions. Like a hollow sphere is present, it looks like, that is called as a shell. So n equal to 1 we call it as a K shell. It is a SPDF orbitals. Orbitals also you can take. Orbital is a 3-dimensional ones, orbit is a 2-dimensional. N equal to 2 is nothing but equal to L shell. We are taking the single electron excited to these particular orbits we are talking, but if you take other than hydrogen also, the multiple electrons are that means they will be returning into this n equal to 1, n equal to 2. This is called as a K shell, L shell, M shell, and onwards. So when the electrons are exiting taking place into the inner orbits, you will get a characteristic spectra. Then in terms of the K alpha, K beta, like that we mentioned. That point we are not going to discuss now. But the characteristic spectra is corresponding to characteristics of the particular element corresponding to high Z values. So for the express spectrum purposes, we require high Z values, and energy level difference is not too high for the hydrogen atom. Therefore, hydrogen do not produce X-rays. Next, second problem. In the hydrogen atom, you are given that N2 equal to 4 and N1 is equal to 2. For the same transition in the helium atom, what is the corresponding wavelength produced? In hydrogen atom, wavelength is given as 20,397 units, means units can be meters or centimeters, whatever it is, or angstroms maybe. The relation for this you will get from the N1, N2 same transitions levels. This is part is same. Wave number equal to 1 by lambda equal to R into this transition orbit numbers related to 1 by N1, N1 square. This is constant. So for hydrogen, if you have taken 1 by lambda is proportional to R. For helium, you have taken 1 by lambda. Helium is proportional to Z square R. Taking the ratio of these two, R cancels, this bracket portion also cancels. Lambda inversely proportional to Z. This is for Z hydrogen and Z helium. The relation, if you substitute, no, helium Z equal to 2, hydrogen Z equal to 1, the relation is 1 by 4, you will get, therefore lambda helium is nothing but equal to, whatever lambda hydrogen is given, this hydrogen, this is a helium, hydrogen by 4, dividing this by 4, you will get this as 5099 units. Next, question number 6. In a given atom, 2 electrons are present and they are having revolving around the nucleus in the different orbits, R and 2R. R1 is R, R2 is 2R. What is the ratio of the square of the time periods? Or simply they sometimes call it square of the periods. Square of the period means time period only you have to take up. This electrostatic force of attraction between the electron and nucleus is equals to centripetal force, which can be written as mv square by r or m omega square. Omega means angular speed or angular velocity. Then omega is equals to 2 pi by t. From substitution you will get the expression for the time, this t, and this r into r square becomes equal to r cube you will get. So the expression for this time period you will get is t square is proportional to r cube. They ask the ratio of the time periods or ratio of the square of the time periods. You have to be careful with this part. Ratio of the square of the time period they asked means directly you can take it as t1 square by t2 square equal to r1 cube by r1 cube by r2 cube. R cancels, you will get is 1 by 2, cube is 1 by 8. Sometimes if they ask the time period square means what a t time period ratios t1 by t2, if they ask that is proportional to r to the power of 3 by 2 you have to take. If the time period ratio, if they ask time is proportional to r to the power of 3 by 2. One more thing is, in these relations, this equation is applicable even for the planetary motions. Planet revolving around the sun has the time period square is proportional to r cube also. There you will get the proportional constant in terms of the gravitational constant g. Here you will get the proportional constant in terms of this electrostatic constants. Next is in this expression, frequency, if they ask frequency of rotation, time period is frequency equal to 1 by time period, reverse of this you will get. Angular frequency means omega, it must relate to the time period you will get. Another thing is for the Coulomb inverse square law. When you take the Coulomb inverse square law, the Coulomb force is inversely proportional to r square. So when you take this F is inversely proportional to r square, what you get is t square proportional to r cube. But in case if you are taken this F is inversely proportional to r square is the Coulomb's inverse square law, t square proportional to r cube. If they are given special cases, F inversely proportional to r to the power of n if they are given, then how to get this expression is t square is proportional to r to the power of 3. 2 becomes 3 means 3 become, this n is given n plus of this becomes equal to n plus 1. Careful with that terminology. T square is proportional to r cube because F is inversely proportional to r square. R cube it becomes. If you are given r to the power of n, if it is given this t square proportional to r to the power of n plus 1 it becomes. Next, let it be. Next, 11th question. Energy difference for the first two levels of hydrogen atom is, first two levels means ground level, ground state, n equal to 1 is minus 13.6 electron volts, and the next one is n equal to 2 is minus 3.2 electron volts. Energy inversely proportional to n square. Substitution, if you take you will get the expressions for the difference. Difference becomes equal to 10.2 electron volts. Electron taken excited from the ground state to next level is nothing but equal to given as energy difference for the first two levels means ground state and next level is 10.2 electron volts. For another atom of the mass number 20, mass number we don't consider only for these transitions, that is only given the weight. Consider only atomic numbers, that is a 10. The corresponding energy difference is how much? Corresponding energy difference is how much? Energy difference is proportional to z square you will get. Equal to HCF S lambda is related to z square for the same transitions they have given. So energy difference is nothing but equal to z square z by z2 by z1. Relations you will get is equals to 100. So delta E2 equal to 100 times delta E1. Delta E1 is given as 10.2 electron volts. Multiplying the term you will get as 1020 electron volts. Next important question is energy difference, angular momentum difference between the adjacent levels. Angular momentum is given by the formula mvr equal to nh by 2 pi according to the Bohr's second postulate. N value will take equal to 1, 2, 3 and so on. If n equal to 1, ground state, n equal to 2, first exit state, n equal to 3, second exit state. Adjacent, successive means adjacent levels if you have taken, for example 2 and 3, 2H, next is 3H, 3H minus 2H is 1H only. That means the difference between the successive levels becomes equal to that of ground state, that is H by 2 pi. The difference in the angular momentum of the adjacent orbits is equals to H by 2 pi, which is equal to ground state value. Next problem, 29th one, binding energy, where I did it as a BE of electron in the hydrogen atom is given as 13.6 electron volts. Find the energy required to remove the electron from the first exit state of lithium atom. For hydrogen atom, that is equals to 1, and ground state they are told. Binding energy not told ground state, but the value, the 13.6 electron volts, that is supposed to be the ground state only. So energy of the total energy equal to 13.6 electron volts. What is the formula for the energy have? 13.6 minus 13.6 z square by n square. And what is the binding energy? It is the total energy expressed in the positive value. This is nothing but ionization energy. Binding energy is also equal to ionization energy. Energy required to remove the electron to the infinite separation from the nucleus, it is also equal to energy required to form the atom by bringing the electron from infinity to the particular orbit. So binding energy is also excitation energy, same relationship, and that is equal, numerically equal to, or magnitude, it is equal to magnitude of the total energy, but you have to take it as a positive values. Total energy formula is minus 13.6 z square by n square, so binding energy same value but positive value, you have to take it up. For hydrogen atom, it given 13.6 means n equal to 1, z equal to 1. So binding energy given as 13.6 electron volts positive. For lithium, that is equals hydrogen, helium, lithium. Lithium, that is equals to 3. N is equals to 2 because you are asked the first exit state. First exit state means n equal to 2. When n ground state is n equal to 1, first exit state is n equal to 2. So energy, total energy of the lithium becomes equal to minus 13.6 into z square means 3 square by n square means by 4 for the lithium. Z is equals to 3, so 9 by 4 it get. The calculation becomes equal to this minus sign I mentioned. Negative sign you will get for total energy. This is the total energy. But binding energy is a positive value, same value, that becomes equal to 30.6. You can calculate this value. What you get is 30.6 electron volts, which is a positive. Binding energy and excitation energy are positive values. Potential means same value, 30.6 volts we can say. Next question number 33. For n equal to 3, the total energy is given as equals to E. For the particular atom in the electron in the exit state, and given that n equal to 3. N equal to 3 means ground state n equal to 1, first exit n equal to 2, second exit is n equal to 3. But they didn't talk about excitation conditions. What they asked is find the expression for potential energy. The total energy is supposed to be negative, but they haven't given the symbol E. E inside it has the value negative. Total energy, kinetic energy potential energy relation is total energy equal to kinetic energy minus of kinetic energy. E is equals to potential energy by 2. Get with the signs. Total energy is minus of kinetic energy equal to potential energy. Kinetic energy is always positive, potential energy, total energy are negative ones. You are asking this potential energy equal to 2 times total energy, 2 times E total. Don't take a minus sign here because E total already given as E, that itself inside contains the negative sign. So potential energy is simply 2E you have to take. Don't take a minus 2E, you have to be careful here. What about the kinetic energy? Kinetic energy becomes equal to, this is not asked, but it's no. Kinetic energy is minus of total energy. Minus of total energy means minus E. This E value inside is negative, minus of minus is plus. Kinetic energy is always plus, and potential energy is always, and potential energy is minus, and total energy is minus. This total potential and total energy minus is the condition specific case when an electron is bound to the nucleus. If these two are positive means electron is not bound to the nucleus. When electron is bound or not, electron kinetic energy is always you take for take positive in any cases. Next problem number 5 in the level 2, the problem numbers may be changing. You are given that energy levels, this is energy level value 0, E, this next energy level is E, next is 4E by 3, next is 2E. Electron is jumping from 2E to E. When electron is jumping from transition from 2E to E, the wavelength emitted E is equals to lambda 1 they gave you. Energy difference equal to, producing the wavelength equal to lambda 1 as lambda given. What is the energy wavelength produced when electron is jumping from 4E by 3 to E they asked. Lambda 2 we have to find out. So what is the relation we have is energy difference equal to Hc by lambda. So first case if you have taken delta E, change in energy difference equal to 2E minus E equal to Hc by lambda 1. 2E minus E is E only. E is equals to Hc by lambda 1. So this is the first case. Second case is that, this is the first case. Second case is 4E by 3 to E, the transition is there. 4E by 3 minus E. 4E by 3 minus E is energy delta E. is equals to Sc by lambda 2. 4E by 3 minus E LCM if you take, it is equals to E by 3. E by 3 equal to Sc by lambda 2. What is E? We got the previous expression, E equal to Sc by lambda 1. So this becomes equal to Hc by lambda 1 into 3. 3 lambda 1 is equals to right side is Sc by lambda 2. Hc cancel it out. What you get is lambda 2 equal to 3 times lambda 1 is the answer. Next, last problem I want to discuss. Remaining problems, any hint you can, I gave you the material already. I posted that material, you check up the answers or hints for them. Remaining problems. Any doubts, please ask me by WhatsApp only. I may not receive the phone calls. So message me only. Next problem number. This problem is a very important one. Almost every year they ask it. This is level 1 problem only, 55 question number. Elements with the principal quantum number more than 4 are not allowed if elements with the principal quantum number means orbit number actually it is. More than 4 not allowed. Not allowed. Then how many elements are possible, are present, are possible to have, or existed? Possible to exist. Elements means here elements in the periodic table. How many elements, hydrogen, helium, lithium, etc. How many elements would have been present if now principal quantum number n greater than 4 is not permitted? Means greater than 4 not permitted means n equal to 4 up to we can take. So if you take the orbitals, this is a nucleus, first orbital, second orbital, third orbital onwards, k shell, l shell, m and next n onwards, n equal to 1, n equal to 2, n equal to 3 and permitted is up to 4. So we can have n shell, n equal to 4. Electrons permitted in the each orbital is given by the formula, or nth orbital we can give the formula. Number of electrons permitted in each orbital is the 3-dimensional relationship, is equals to 2n square is the formula. In nth orbit or orbital, the number of electrons they can fit. This is not for hydrogen atom, please. Hydrogen atom only one electron jumping place, but if you take any other atom, multiple electrons are there means also they will sit in the particular order. The number of electrons in the particular shells possibility is equals to given as 2n square. If you take the first case, n equal to 1 if you have taken, that is a shell which is very close to the nucleus, then number of electrons possible is equals to 2 into n square means 1 square, which is equal to 2 electron can fit. In this s orbital we can also call it as 2 electron can fit. Next is, that is a k shell, n equal to 2, second orbit. When second orbit you have taken, n is equals to this n1, n2 is 2 into 2 square, which is equal to 4 into 2, 8 electrons can fit. So in this L shell we can fit 8 electrons. Next n equal to 3, then n3 is equals to 2 into 3 square. 3 square is 9. 9 to the 18 electrons can fit. Next is n equal to 4. n4 is equals to 2 into 4 square. 16 to the 32 electrons possible. So now total number of electrons possible, because up to n equal to 4 only permitted, n equal to greater than 4 not permitted. n equal to 1 to 4 permitted, n greater than 4 not permitted. Then total becomes equal to 10, 10, 60. Total number is nothing but equal to 60 electrons possible. And for the neutral atom, number of electrons, if you take neutral atom, number of electrons equal to number of protons, which is equals to number of elements possible. So number of elements possible in the periodic table would have been only up to 60.